2, go.
Hello, future class of Thermo 2. I assume that you're watching past us explaining entropy to you. And I assume future me is there too. Hi, future me. You're looking fine.
Today, class, we are going to discuss the wonderful world of entropy. But what is entropy? Entropy, which is an important thermodynamic aspect of all chemical reactions, is the never-ending characteristic of thermodynamics. Entropy is often considered the measure of disorder in a system and is typically denoted by the letter S and measured in joules per Kelvin mole. However, entropy can also be considered the probability of a system occurring. Every system contains some degree of disorder, and even a single element or molecule as particles. Every substance contains some degree of disorder, and even a single element or molecule as particles are always in a constant motion, and therefore S is always a positive number. Since disorder is so close to entropy, you could think that this pop can is our system, and if I shake it up, it will go into a state of disorder.
Oh, this is the worst! Now, how can I illustrate the principles of entropy even more to you? Let's find out. Say, hypothetically, we tie Joe up with ropes.
Yo, you guys, let me go! No one told me about this part! Let me go!
This would represent Joe with little entropy, for he is not moving or saying, oh, too much. But now let's say we douse Joe in gasoline and light him on fire. Would this represent a more disordered system? I believe so. Hey, Mike, do you have the fire extinguisher? No, Mike, that's a bat. No, Mike, those are the matches. We need fire protection. There we go. That's the fire extinguisher.
Ah, it burns! It burns!
I got this!
This is more painful than thermo test 1!
After I commit arson, it always reminds me that a good way to imagine entropy is to think of it in these three as the three states of matter. Gas has the most entropy, for the molecules are not touching each other and are always bouncing around. Liquid is in between gas and solid, as the molecules are moving and hitting each other, but are not always. And solid, of course, has the least amount of entropy and is the most ordered. But what about when a system changes? Say from ice to a liquid water, the system is gaining entropy. Or let's say when you increase the number of moles in a system. If we have 1 mole of nitrogen tetroxide and it decomposes into 2 moles of nitrogen dioxide, our system is gaining entropy. I hope that you have learned something today, class, and I really hope that those burns aren't as painful as they look.
I can't feel my legs!
Until next time, we hope that you like thermodynamics too, and keep